Other thing is, in this RAM generators, that spectral density problem is there. Spectral density means in this RAM generator, we have to consider, for example, in previous slide, that you have seen that, for example, in this downlink frequency, that from the Airtel is starting from 925 to 930, 31, something like that. So, if we want to generate that frequency band, it is a huge bandwidth. So, what will happen if we do this RAM generating part? The output is spread throughout this bandwidth. So, spectral density of this is very low. So, because of that reason, this outdoor jamming, this proposed method is I will introduce for this. So, what is method which I did? Here, before that, these are the problems that I faced when I designing a one for outdoor. So, when you going for the outdoor jamming, the jamming signal strength is very weakened throughout the jamming area due to the multipath reflections and absorption and attenuations. And other thing is, it is very difficult to concentrate onto the particular area because we cannot see radiation, we don't know where it will be reflecting. And the signal strength receptor from BT is greater than in outdoor if we compare the indoor, because indoor means it is attenuated, but if we go to the outdoor, the signal strength is very high. And also we required a high output for outdoor jamming. For indoor jamming, we required only in this jammer is just a one output, less than one, but it is concentrated within this classroom. But if we going for the outdoor jamming, we can't do that. We required at least 40, 60, maybe it's going to up to 100 volts. Once the output is higher, what are the next problem we face is heat dissipation, because it is generating huge heat. So we have to get precautions to cooling something for these amplifiers and these circuits. Another thing is we have to get more precautions on lightning and this voltage surge is coming on these power lines. Before going on to this proposed method, I just give the ARFCN and URFCN. ARFCN means in GSM cellular network, an absolute radio frequency channel number is a code that specifies a pair of physical radio carriers used for transmission and reception. For each uplink frequency and the downlink frequency, there is a particular ARFCN number. It is internationally standard one. Then when we are going for this 3G communication, this UMTS is there. UMTS also, that particular number, it is for the 3G communication. If you go into this proposed method, there are mainly three parts. One is that power supply, then the IF section and the RF section. We will go one by one on this. First one is this power supply. If you get the power supply, normal AC power once inserted here, because that I specifically mentioned 13 volt, not because of anything, because for the ampere, this amplifier, I use this OPA amplifiers. So OPA amplifiers, because we require to give 13 volts. That because of that 13 volts is there, it is depending on the amplifier input voltage. It is DC, so and nearly it required 28 amperes. Yeah, for that I use switch mode power supply. Then the regulator, and it will give the 5 volt to the circuits and RF amplifier. So in this IF section, what it's doing, each of this, it means there's a separate. We have to generate particular frequencies, and for that we have to give particular voltage for each of that frequency. Because for that I use this normal preset. From that preset, give the particular voltage for the VCO. In the microcontroller, it will switch these frequencies one by one. So each of the band, which means if you say that Mobitel frequency band, then Mobitel frequency band is particular frequencies we have to give. according to the ARFCN which is on the particular area. So I can concentrate total power onto that particular ARFCNs only. So then once we generated that particular voltages, it is stripped from the microcontroller and it will give to the VCO. Before that, I also generated noise generator using a PWM signal from the same microcontroller, and it mix it up and insert to the VCO. So this is microcontroller. It is normal microcontroller. It is 28 pin 16F8761. So for information, these are the frequency band. It is used by particular service providers in Sri Lanka. Airtel, Mobitel, likewise, they are uplink and downlink frequency band in 3G and 900 and 1800. And this is the way that noise is generated using this microcontroller. The other thing is, in the RAM generator, it is very difficult to jam the 3G. Right? Why? Because this 3G is spectrum. So in my method, I use particular ARFCN and give the high maximum output for that. So it is throughout the period, it will give particular output on the particular URFCN signal. So 3D also can jam. So these are the VCOs that I use for this, and I'll really show you some. These are the observations. First one is that from 900 band. In the first one shows that when the jammer is off, the second one is jammer is on. It is efficiently, it is covered the required one. And the 1800 also same. And 3G is, if you see, if the first one is off and the second one is when it is on, it covers rest of the efficiently. This method is effectively utilize the jamming signal power through the, and the system is successfully completed and it is deployed in outdoor location. Performance of the system is excellent, even though very close vicinity BTS also be able to jam using this jam. Thank you.
Thank you, RMIN Bandara.